What? Now, if any of you have not looked at your book since you've taken the test or since you finished your homework, what? What are y'all laughing about? We're going into chapter 6, which means we're going into algebra. Okay? And algebra is an old-timey word for broken up, basically. It goes back to the Arabic origins of the numbers and talks about breaking up into parts. So, the first thing that you need to go over before you go into algebra is the order of operations. Now, a lot of people have a little bit of a misunderstanding here. They believe that, please excuse my dear Aunt Sally, covers 100% of the mathematics that we do, and that's not correct. If you have a mathematical sentence from left to right, and it is the operation of certain operations, then you just go left to right. And I just want to make that distinction before we go into the order of operations. I always tell this story. You got South Carolina here, and you got Anderson or Clemson up here, and you got Columbia down here. And there's these three fellas from Clemson. They want to go down for the Carolina game. And this is an old joke that's told. And they go down to Columbia and they get a room. They get a room for $30. There's three guys. And they get one room for $30. $30 for the room. And the guy that owns the hotel, he figures out about 15 minutes that that room is $25 a night. And of course, this is an old joke, so it's old prices, okay? So he says it's really $25 a night. So he says he's a very honest man, and he gives his grandson $5, a $5 bill to take back to the three guys. So he gives the little boy $5, or the $5 bill, and the little boy goes halfway upstairs and says to himself, how am I going to give a $5 bill to three guys? So he thinks about it, and he goes back to his granddad, and he changes the $5 bill into 5 $1 bills. Everybody with me? Okay? And he goes back up the stairs, and he gets halfway up the stairs, and he says, how am I going to give 5 $1 bills to three guys? And he said, I'm not going back to my granddaddy because he'll get mad. So he comes up with taking 2 of the dollar bills and putting in his pocket. Everybody with me? So that leaves 3 $1 bills. So he gives each guy $1 apiece. And how much does that mean that they gave for the room? If they paid $10 apiece, then that would be $1 off. That'd be what? $9 apiece. 9 times 3 is what? Plus the 2 that he has in his pocket. Where'd the extra dollar go? Where'd the other dollar go? There's the 3. I only took off 2. Where'd the dollar go? No. Each one got $1. He took 2. He took 2. What? Anybody know? No. He gave each one of them $1 apiece. And 2. I erased 2 right here. There's still 3 right there. I didn't change anything. He gave each one of them $1 apiece. They paid $9 apiece for the room. 9 times 3 is 27. Plus the 2 that I erased is 29. You win all kind of money on this thing. What did I do first? I subtracted, then I what? You're not supposed to subtract before you multiply. And that's why you get $1 off. In other words, you can't subtract before you multiply with this problem. It's, you could take 2 minus 1 times 3. And you can take 2 minus 1 times 3. Do this first. 2 minus 1 is what? 1. What's 1 times 3? 3. Negative 1 times 3 is what? 2 minus 3 is 1. So, order of operations make a what? Makes a difference. Makes a big difference. And if you get the numbers to work just right, you can get the difference between those two numbers to be exactly 1. You just have to work with the numbers and the operations. And that joke right there does that. You start off with $30. You talk about 25, and you talk about 5, and you have 5 right here. But when you explain it, you have people subtract before they multiply. And you get, let's see which one, okay, you get this number instead of the correct number. And that's why you have to be careful. Now, I explained it a little oddly. There's 2 operations in mathematics. There is addition and subtraction, and then there is multiplication and division. Now, why did I put these 2 together, and why did I put these 2 together? Exactly. They're the opposite of each other. And they undo each other. It's kind of like they argue all the time. This one undoes that one, and this one undoes that one. This one undoes this one, and this one undoes this one. They always opposite of each other. What 2 blood relatives fuss and fight all the time? Brother and sister. So if you have brother and sister in a mathematical sentence, now what is a mathematical sentence? Well, it's a mathematical sentence. It says 2 minus 3 plus 7, blah, blah, blah. That's a mathematical sentence. You go in a math sentence, you go left to what? Right. Okay? I'm sorry, I was supposed to have a fifth. In a math sentence, you go left to what? Right. Give you an example. I'm going to switch screens right quick. Well, I can do it right here. 2 times 4 divided by 3. Now, if you did any other way, you'd probably get it wrong. But the way that you do it is left to what? Left to right. 2 times 4 is 8. 8 divided by 3 is 8/3. But let's turn it around. Let's put the division first. So let me turn it around. And go 3 divided by 2 multiplied by 6. Well, 3 divided by 2 is 3/2. And then multiplied by 6/1. And what happens here? Your answer is what? 9. Now, if you did it by, please excuse my dear Aunt Sally, what do you do first? Multiply, that's 2 times 6, that's 12. 3 divided by 12 is 1/4. So you're either going to get 1/4 or you're going to get 9. And the correct answer is 9. So please excuse my dear Aunt Sally isn't 100%. If you have brother and sister in a mathematical sentence, you go left to right. Do it there. Three minus 2 plus 7. Go left to right. 3 minus 2 is 1. 1 plus 7 is 8. Now, sometimes they will work out to be the same, but sometimes they won't. And it's up to you if you want to take that chance. Always remember, when you're in a mathematical sentence, left to right. And they have to be brother and sister. Now, Hubert, what about, please excuse my dear Aunt Sally? Well, if you crisscross these guys, eventually I'll get to the right thing. If you crisscross these, and that minus symbol is supposed to be up here, I just think I just might as well quit. What do y'all think? If you crisscross these brothers and sisters, I like to tell students they're cousins. And if you have cousins in a mathematical sentence, cousins go to Aunt Sally's house. And Aunt Sally is what? Please excuse my dear Aunt Sally. And it goes left to right. And what is please? What's that? Parentheses, exponents.
Multiplication, division,
There you
addition,
go.
subtraction.
There you go.
Now, can't the E also be another P for parsing for powers and parentheses?
I don't know anything like that. That might be another teacher's thing. This is a Hubertism. You ain't gonna ever see brother and sister and Aunt Sally together. That's mine. But Aunt Sally has been around. And I realize that there is other teachers that do not teach Aunt Sally, and they PEMDAS. I had a student one time, and all she would say when I was doing this is, "I don't know that. I know PEMDAS. I know PEMDAS. I know PEMDAS." I want to tell her just to shut up. She had this very annoying nasal thing going on. PEMDAS. That's all I know is PEMDAS. I don't know what Aunt Sally is. I don't know what. Shut up. It's the same thing. But anyway. So if you have a mixture of these, then you go to Aunt Sally's. And that is the difference. And some people don't know the left to right rule. And it's not that big of a deal because you don't see a lot of those. Most of the time you're going to see, please excuse my dear Aunt Sally, about 90% of the time. But there will be times that you have a mathematical sentence with just the two operations here, or just the two operations here, and you just go left to right. Like that. Now that problem is, please excuse my dear Aunt Sally, because these two guys are cousins. So what do you do first? You multiply. 2 times 4 is 8. 8 minus 3 is 5. If you have cousins, please excuse my dear Aunt Sally. All right? Again, you have cousins. You have multiplication right here. You have subtraction. You have plus, and you have division. You've got all 4 of them right there. The first thing you want to do is work on that exponent. So 3 squared is what? 9 minus 4 plus 3 divided by 6. What was that failed? I thought I heard something off. Oh. Now what? Well, 3 divided by 6 is what? 1/2. 9 minus 4 plus 1 over 2. And now you got to have what? Common what? Denominator. So 2 minus 2 plus 2. And that's going to give you 18 and 8 and 1. And what's 18 minus 8? 10, and 10 plus 1? 11 halves. So you got to be careful. You can't just assume, please excuse my dear Aunt Sally, because sometimes you have to do, now this hadn't been a division symbol. If this had been a plus, then you would have went what? Left to right. Not a lot of people know, but you do go left to right. If this had been a plus, if that had been a plus, you would have went 9 minus 4 plus 3 plus 6. Left to right.
Why just when you divide 3 and 6 and get 2 and not 1 of those?
3 divided by 6 is 1/2. 6 divided by 3 is 2. 3 divided by 6 is 1/2. Right here. 3 divided by 6 is this. And what's 3 divided by 6? 1/2. Well, that is that. That is that. You can't divide a big number into a small number. You're always going to get a fraction. All the time. Now, leads me to two rules that you need to, or two words that you need to know. Evaluate and determine. When you see those two words in a set of directions here in this chapter, that means plug and what? Plug and chug. What does plug and chug mean in mathematics? Plug in the numbers and chug out the what? The math. If you've never heard of that before, I find it amazing. Especially if you've been through 12 years of school and never heard of plug and chug. No, this time of day, this day and time, I would not be surprised. But it's an old term called plug and chug. That ain't a Hubertism. That's been around a long time. You can go to Google and no, you better not. It might pull up something bad. Urban Dictionary or something. Anyway, evaluate and determine means plug and chug. The difference, evaluate, you're going to get one number. Determine, you're seeing if the two numbers equal each other. Okay, so determine is a number equal to another number. And evaluate just comes out to be one number. And I'll show you what I mean. Evaluate. And there's my directions. And I got 2x plus 4y. And x is equal to 3. And y is equal to negative 4. So what am I going to do with 3 and negative 4? Plug it in. Plug and chug. So whenever you plug in something, you always use parentheses. And then you plug in what here? A 3 and negative 4. And 6 minus what? 16 is equal to what? Negative 10. How many numbers did we get? We got one. Negative 10. So we evaluate. Evaluate, you get a number just like 10 or negative 10. You're going to be given this. You're going to be given an expression, which means no equal sign. You're going to be given an expression made up of terms, and you're going to be given those variables to plug in. And most of you are pretty comfortable with that because you've done it before. Determine, I don't know if you've done it before or not, because you don't usually get into determining if something is a solution till you get to algebra. Determine if 5 is a solution. And that's what it'll say. 2x plus 4 is equal to 3x minus 7. And they give you x is equal to 5. That's what they're giving you. So x is equal to 5, 2 parentheses plus 4 is equal to 3 parentheses minus 7. 5 goes here and here. What's 10 plus 4? 15 minus 7. Are these two equal? No. And therefore it is not a solution. And we got two numbers determine two numbers, evaluate one number. And that's how you do 6.1. On the test, you're talking about one or two questions on the test. Not very important. I mean, it's important, but it's not the objective of Chapter 6. The objective of Chapter 6 is to learn how to do algebra and graph. Okay? What does 6.2 talk about? Well, if you look in your book, 6.2, I think you actually start talking about algebra. Well, you start talking about algebra in the first one, but anyway. Let me get to the book. Well, I can't get the screen to work. Doo-doo-doo. That's evaluate, all that, that's determine. And then we get in there, linear equations of one variable. Now, most all students that come to 155 can do the one-step equation. 6.2 is basically algebra. Most of you know that the main objective of algebra is to get the variable what? By itself. Once you get the variable by itself and positive, once you get that variable by itself, you have found the unknown part of the sentence. And we do that by the theory of equality. That basically what we do on one side, we can do what? Exactly. Theory of equality. What we do on one side, we do on the other. And most of you have been taught that in either pre-algebra or algebra 1, and that's not a problem here. I know most of y'all can probably do them with no problem. But that's not where students get confused. Where students get confused is when you add the other stuff to the algebra. The fractions, the decimals, the 2-3-step equations, the combining like terms, the distributive law, the negative across terms. That's where students get kind of bogged down. So what we're going to do is we're going to start off with basic operations like addition, subtraction, multiplication, and division. And everybody in here can do these pretty much in your sleep. X plus 4 is equal to 7. We want to get the x by itself. We got to get rid of the 4. How do you get rid of a positive 4? You subtract 4. Some people don't say that. Some people say take it across the river. And it turns into a negative 4. It turns into the opposite. I don't care which one you do. You still going to get the same answer. X is equal to what? 3. You take 3, you plug it in, it is the solution. 3 plus 4 is 7. 7 is equal to 7. That's how you check it. You always check. That's the way you check algebra. Is you take the unknown variable, what you found, and you plug it into the original. X minus 5 is equal to 12. How do you get rid of a negative 5? Or do you take it across the river, whichever one you want? It becomes positive 5. Either way, you get 17. (3x) is equal to 21. Here you are multiplying by 3. You don't want to multiply by 3. You want to get rid of it. So what do? You either multiply by 1/3 or you divide by 3, whichever one you want to call it. And you get x is equal to 7. And then division, x over 4 is equal to 12. How do you get rid of dividing by 4? You multiply by 4. And x is equal to 48. Now again, these are all elementary little starters to start off with, but this is not going to be on the test. Parts of it will be, but not those basic questions. They're going to be more advanced. And what you're doing, nobody's ever going to walk up to you and ask you what x plus 4 is equal to 7.
Nobody's ever going to ask you that.
But what you're doing is you're taking a mathematical sentence. 12 plus 5 is equal to 17, and you're breaking it up into its parts. You're breaking it up into something minus 5 is equal to 12. Or that's what you've been given. It's kind of like, when you're given a mystery or you're given something that's not working at work, and your job is to find out why it's not working. You don't just go, okay, it's not working, I can't fix it. You don't do that. You try to break it up into its parts. You try to figure out, and I'm not just talking about mechanical. I'm talking about human relations. I'm talking about management. I'm talking about financial. You can have a financial problem in your workplace. You can have a personnel issue in your workplace. You can have a human resources. You can have all kinds of problems besides mechanical. The first thing you do with a problem is you break it down to its what? Its parts. And that's what algebra teaches us. It's just like if you were given the job of being the customer service manager at a store, and your job was to handle customer service when they come into the door raising Cain. And I'm serious. I'm being serious. You would not take that job lightly if you what? If you depended on it. In other words, if you knew that job was your only job, you would do it, like you're supposed to. Like you're supposed to do any job. You would do it the best you could. All right? Somebody walks in, and you go, what does this have to do with human resources or customer service? If you're just sitting at the customer service desk and you're working on whatever, and you see a woman walking in, and she's got a very disgusted look on her face, what does that tell you? She's mad, okay? You're assessing. You're figuring out what the problem is. You already started before she comes up there. So you already tell yourself, okay, this woman is in a mood. So I better try to get her calmed down as soon as I talk to her. You don't sit there and go, okay, this girl's going to be a bitch. I'm going to be a bitch back. Yeah, you're going to get fired. And there goes your money for the week or the month. Now, I'm not talking redneck bill, okay? We're talking about you need this job. And somebody puts you in this job, and you have a problem coming up. First thing you do is assess. That's what we do. We do an assessment. Then you say, may I help you? And then you're going to find out what the problem is. And you find out what the problem is. You go, oh, well, I can't help you. You're fired. You lose your job. You don't have baby food for the babies. All right? Or do you say, what department did you get that out of? Or who did you talk to? What are you doing? You're taking the problem apart, and you're trying to show the woman that's mad, you're trying to show her that you want to help her, and that the store will stand behind whatever she's fussing about. And then she walks out happy, and then your manager likes you because you've done your job well. That's a problem that you could have. Now, I know I've kind of made it dramatic, but there's all kinds of problems in the world. Anybody that goes, oh, well, I'm never going to use x plus 7 is equal to 4, you're redneck, shut up. Because you're missing the whole boat. Problems have to be taken apart. And then you have to figure out which part's not working and replace it. Or fix it. One of the two. All right. So, let's let's talk about some of the things that can be added to a problem. We can take that x plus 4 is equal to 7, and you don't have to write this down. And you can put a 3 in front of it. And there you got a distributive law. You could put a negative 3 in front of it. That changes it all together. You could put a 1/2 out front, and then y'all skip it. Y'all don't even do it. Okay? You could say 1/2, and you could take this off right here, and you could say plus 16 is equal to 1/3, and you will skip it. You won't do it, or you'll try to do it. There's all kinds of things I can do to one equation and make you skip it. So what we're going to do is we're going to make sure that you don't skip it. And I'll spend 2 weeks on this because I don't want anybody skipping problems just because they think it's hard. Because all the problems that I do can be done right here. No calculators needed. Because we clear everything. We clear the decimals, we clear the fractions. That's why I make sure you know how to find the common denominator, because in algebra, if you can find the common denominator, you can clear any fraction. And then the problem is a whole lot easier. People can't do algebra because they can't do what? Fractions. That's why people can't do algebra. People can't do calculus because they can't remember the algebra. It's all stair-step. So, let's talk about the distributive law. I don't know if any of you have ever dealt with concrete before. I have. And I'm not talking about concrete that's already cured. I'm talking about concrete that you pour out of a bag and mix up with water. You ever dealt with that before? Okay, nobody's going to talk to me. All right. Let's say I got a box that's 6 inches by 1 foot by 1 foot. And I want to make a base for I don't know, something to stand up in my den. I don't know. I want to make a base so it won't turn over. And a gumball machine. How about that? Some people like antique gumball machines. I do. I like antique stuff. So I found an antique gumball machine that doesn't have a base on it. So I'm going to make a base for it. And I'm going to take some bolts and I'm going to stick them up like this. And anyway, I'm going to use this because it's heavy. So I'm fixing it and I'm making it smooth and everything. And while I do it, I lose my ring. And that ring, you know, guys, we don't notice things until a week or two later. Y'all women, y'all notice it like a millisecond after. But anyway, my ring is in there. And I don't even think about it until the next couple of days. And how am I going to get that ring out of that concrete block? Because what's happened to the concrete? It's cured. You take a big hammer and you break that concrete block up into what? Pieces, and you'll get your ring back. So let's talk about this. Your objective is to get what? The ring. Your obstacle, as you say in Oh Brother Where Art Thou? Your obstacle is the cement block. And the tool that you're going to use is what? The hammer. You with me? What the heck does this have to do with algebra? Well, what's your objective in algebra? You get the variable what?
Right,
So that's your ring. What's the parentheses? That's your concrete block. And what's your hammer? Your hammer is the 2. Oops, I don't look like a hammer. I suck. Alright, let's do the hammer again. I don't look like a hammer either, but anyway, that's your hammer. And what do you do with the 2? You distribute it, you multiply it times the x, and you multiply it times 4, and you have an equation. And you get 2x plus what? Is equal to 17. Take the 8. This is a multi-step equation. What I tell students here is you're standing on the equal sign. You reach out for the x because that's your ring, that's your objective. What's in the way? The 8. How do you get rid of a positive 8? You take it across the river and it becomes negative 8. And you get 2x is equal to 5. No. Equal 9. And x is equal to 9 halves. Now, what's the problem with distributive law? Not really a problem until I put a negative out there. And then that's when people have problems. So let's do one with a negative, because that's pretty self-explanatory. And 2, we don't have a problem with the 2 because 2 is a whole number. What if I have a fraction out there? Well, that's another problem. Skip. Y'all leave it alone. Y'all won't do it. So let's do a negative. Now, what you need to realize about a negative in front of parentheses, what is the rule that everybody says about a negative in front of the parentheses? What does it do? It what? It turns everything the opposite. That's what it does. If you distribute this negative with this and this, what does it turn? Don't worry about the 2, okay? What's a negative times a positive? A negative. And what's a negative times a negative?
Positive.
So it changes the sign of everything in brackets. And that's where students kind of bog down. They forget to do that, and then they wonder why they get it wrong. That's why. So let's distribute. Take the hammer and bust it up, and we get negative 2x plus what? Is equal to 16. And now you have an equation that you can work with. You take 6 across the river, and you get negative 2x is equal to 10. Now, the main objective of algebra is to get a positive variable by itself. I don't want this negative 2 over here. I'm multiplying by negative 2. How do I undo multiplying by negative 2? You divide by negative 2. And whatever you do on one side, you do on the other. X is equal to negative 5. So you've got to remember one thing, and that is the negative changes everything in the parentheses. Okay? Well, people say, well, that's still no problem. Well, the biggest problem I see with students is fractions. That's where you start having problems. So, what if I give you 1/2 x plus 3/4 is equal to 7? Well, the first thing some people would do is reach for what? A calculator and start changing everything into decimals. Well, those are the people that can't make change at the cash register. Take and clear the fractions. First of all, make everything a fraction. 1/2 x plus 3/4 is equal to 7/1. Now, what is the common denominator of 2, 4, and 1? 4. 4 is your common denominator. So I'm going to multiply through And I'm going to put a baby step in here for you. We'll multiply through by 4 over 1. So here's the baby step. I'm going to write it 3 times. 4 over 1, 4 over 1, 4 over 1. And then I'm going to rewrite my equation. 1/2 x plus 3/4 is equal to 7 over 1. And of course, they're multiplying because I just distributed, so they're multiplying. And what's going to happen to your fractions? They're going to cancel out. And that will happen every single time. And then you're left with a pre-algebra problem that anybody can do. Given a problem, assessing what to do, making it easier. 4 divided by 2, 2x. 4's cancel, 3 is equal to what? Now, I don't know about y'all, but I would much rather work with this than work with this. Math is not hard, but it's all how you were taught how to do it. And if you were one of these people that were given a calculator and say use the calculator, then you did not get your money's worth. So don't raise your hand and say I did or I didn't. I'm just telling you. You should have been taught this since the get-go. So minus 3, you get 2x is equal to what? 25. X is equal to 25 what? Halves. Now I can put fraction into parentheses. 1/2 times x minus 4 or 7 plus 1/3 is equal to 4. Now clear the fraction on that one and finish it. And if you can't, just meditate. Huh? No. You don't want to do it today. You just don't want to. You are kidding me. I'm glad that you attended class. Why? Where do you work? What? Oh yeah, that's right. Which one do you work out? Because Miss Poland works at... Which one do you work at? Okay, Miss Poland works at the one on Clemson Boulevard up there. Or is it still up there? Miss Poland. She's in one of my other classes. She's... Huh? It's always been called Clemson Boulevard, yeah.
That part of the street's actually North Main.
Whatever. Okay, where does it turn into Clemson Boulevard?
It doesn't turn into Clemson Boulevard. It's to where that red light is, where it's Metro Fashion and all it is. From there up is Clemson Boulevard. From there down is North Main.
Okay, from what road?
You know where the red light is right there that comes out where there's DV's liquor store and the BP and the Quality Inn and all that?
Yeah.
All that starts Clemson Boulevard. Anything on the other end is North Main.
It's always been called Clemson Boulevard. To me, North Main, North Main is down there at the square. You know, and then about 3 or 4 blocks after the square, it turns into Clemson Boulevard. That's what I always thought. pencil I let you borrow. This class sucks. Y'all just suck. That's what it is. I'm kidding. I know I suck.
I mean, I'm over here like falling asleep.
Thanks.
I think I really did that.
Y'all gonna give me a complex. All right, what's the common denominator of 2 and 3? 6. So you're going to multiply through by 6 over 1. So I'm going to just draw 6 over 1. 6 over 1. I want to ask you a question. How many terms am I going to multiply 6 over 1 by? 3. Good. Not 5. Okay? Because some students try to multiply everything. This is a concrete block. You can't touch this. I mean, you can't. I mean, you ever tried to reach into a concrete block and get a ring? I mean, you break your hand. You cannot touch what's inside here until you distribute. So, I'm going to put a baby step in here. 6 over 1. 6 over 1. 6 over 1. And then 1/2 x minus 7 plus 1/3 equals 4 over 1. And again, we distributed that 6 over 1, so it's multiplication. And what's 6 divided by 2? 6 divided by 3? 6 times 4? And now what? Distribute. What do we get? Minus. Plus 2 is equal to, and y'all expect me to understand that. How am I supposed to understand that? So, now, another rule. Whenever you use the distributive law, usually something is going to follow the distributive law, and that is CLT. Anybody know what that stands for? Combining like terms. And these two are like, because they're numbers, integers. So 3x minus 19 is equal to 24. And I'll take this across to the next page. And we get 3x minus 19 is equal to 24. And what do we do with the negative 19? Take it across the river. And we get 3x is equal to 44 minus 1, which is 43. And divide by 3. And that's your answer. So, make sure you can do algebraic equations. Now that's 6.2. And I'll stop there because I know y'all got tests to take. And I know y'all got 6.1 and 6.2 to do. So I'm going to stop right there. And I'm going to let y'all